In today's class, we're going to discuss domain name system, DNS protocol, the Internet Directory Services, the service provided by domain name system or DNS protocol, and overview of how DNS works. So domain name system. So normally many people many identifiers are available. So how do you people can identify with is social security numbers, or we can identify in the name, so and also passport numbers. So what is the domain name system mean? So the conversion of domain name into IP addresses will gives by the domain name servers or domain name protocol or domain name system, or it is a vice versa. So each the domain name so will gives the IP address or IP addresses into domain name. So that is exactly it is possible in under this domain name system. So normally the normal people can able to identify. So you is social security numbers, names, and passport numbers. So in the internet host or routers, so can be identified with the IP addresses. How exactly the people can identify. So internet every machines are identified with the so is IP address 32-bit IP address or IP version 4 address. So it is used for addressing the so each host so in the datagrams. So names are nothing but so each the servers can identify so with their names. So normally www Yahoo servers. So Yahoo.com are maintained in the Yahoo servers, Yahoo pages, so which are available in the Yahoo servers or Yahoo.com. It is exactly the domain name. So followed by .com is an extension used by the humans. So humans are very easy to recognize these domain names rather than IP addresses. IP addresses are common man cannot able to understand these IP addresses. So that is exactly IP addresses are again class A, class B, class C, class D, like it is exactly divided. And the dotted decimal numbers are it is a 32-bit numbers. It is a millions of billions of IP addresses are not able to remember, not able to. So even the unique IP addresses are not able to. So it is so each and every the Yahoo servers, Hotmail servers, Gmail servers. It is IP addresses are it is so names, domain names. So how exactly IP addresses are unique, domain names also unique. How to map between IP addresses and names and vice versa. So domain names and vice versa. So here, so that is a domain names came into existence. So it is a distributed database. So implemented in the hierarchy of many name servers are introduced under domain names. So this is application layer protocol that is a host. So that is as a the servers, each and the every servers as a domain name servers, or it is also called as a name servers, communicate to resolve the names, address, or name translation. So core internet functions implemented as an application layer protocol. It is a complexity for the network edge. They are maintaining the domain name. So what are the DNS services and structures are available in the domain name system? So as you know that domain names is a mapping of a domain name into IP address and vice versa. IP address into domain name that is possible. What are the services means? So host name into IP address translation. That is a DNS services one and host aliasing. Each and every other name that is a canonical name or alias name will be provided by the host aliasing as a mail servers aliasing that is possibly done by the domain name system. Load distribution, replicate the web servers and many IP addresses correspond to one name that will be replicate. So that is possible with the help of DNS services. Why not centralized DNS? So suppose it is a single point of failure, so that is exactly not sustainable. The domain name system entire and domain name system will be collapsed. So that is the reason. So the hierarchy of the domain name are introduced and to reduce the traffic volume and distant centralized database they are maintained. So maintenance. So that is very easy. So if it is a centralized database is maintained. So it is a maintenance that does not scale well. That is the reason. So domain name is distributed and also there is a so not maintain the centralized database. So here, how DNS is a distributed and hierarchical database. In the first level, the root DNS servers are maintained So as a DNS system servers, that is a root servers. Again, in the second level, there is a .com, so .organized, .edu servers they are maintained. So there is a exactly so .com, .org, and .edu in the second level. So in the third level, so Yahoo.com, Amazon. So commercially, which are the so that is a registered, they are maintained the Yahoo.com, Amazon.com DNS servers. So similarly, in the organization, so PBS, so that is a publishing agency. DNS servers are maintained Poly Video, that is educational website they are using, and Poly.video, UMass.video. So that is exactly three extensions. The military.net, three extensions, ORG organization. So many that is extension, three extensions are provided, and two extensions like country domains. So that is a domain name followed by the two extension. So Australia AS, so that is a AU, and India IN, so US dollar. So like that. Clients want to IP for the Amazon.com. First approximate client requests the queries to the root servers and find the DNS servers and find the .com DNS servers and client again queries to the .com DNS servers, get the Amazon.com. So you see that so always query will be passed on to the root DNS. Root DNS servers exactly sent to the .com. Again, client queries to the Amazon.com DNS servers and get the IP address for each of the Amazon. So Amazon, so that is exactly query will be always passed on to the root DNS servers. Again, it is intern to the .com servers. Again, intern to the Amazon.com servers. It is a get back, and it is these Amazon.com servers. So that is a web servers. Then exactly it is a so send back a requested client. So that is a domain name and the corresponding mapping IP address will be sent. This is exactly so that is a DNS systems contains. So here, so root name servers. So contact by the local names servers that cannot resolve the name. Root name servers contact the authoritative name servers. If name mapping is not known, gets the mapping and returns the mapping to the local DNS servers across the how exactly worldwide. So the names root name servers are worldwide. It is look like. So there is a top level domain servers. There are two types of servers that are maintained here. Top level domain servers, TLD servers. It is responsible for so .com, .org, .net, .edu, .aero, jobs, museums, and all we can call as top level country domains like US, UK. We can already UK, France, .fr, Canada, .ca, Japan, JP. So network solution maintains the server for .com TLD. So EDU, so education site they're maintained for EDU top level domain servers. So authoritative DNS servers, organizations have own DNS servers that provide the authoritative host name and IP mapping for organization named host. It can be maintained by organizations or service providers. So that is authoritative DNS servers. So local name servers. So normally there is a so does not strictly belong to the hierarchy. Each so internet service provider, residential ISP, company, university as a one also called as default name servers. So when the host makes a DNS query, query is sent to the local DNS servers. So as a local cache, recent name to the address translation page, but maybe out of date acts as a proxy and forward the query into the hierarchy. So here is an example how DNS name resolution example. So host is a so this is exactly sys poly.edu. Once IP address from this so GA UMass. So that is exactly this is the site DNS poly.edu and this is the UMass.edu. So iterative queries contact the server replay. So iterative query is nothing but the first step. It is a pass to the local DNS server. Local DNS servers domain name it is not mapped. So with that is a contact to that. So root DNS in turn it is tell to that you contact again local DNS servers. So it is a like poly.edu is a local DNS. It is not available. Contact to that. So top level domain servers. So it is telling that yes, it is under me. It is not available. Again, it is telling to that local DNS server poly.edu. Again, request will be passed on to that. So authoritative DNS servers, authoritative DNS server is maintained by the organization people. So this request will be passed on. Again, request will be, so yes, I am authorized to the dnsumas.edu. This is a iterative query. This is the, so in the step number 7, it is get back to the local DNS server. Again, local DNS server in turn map with the IP address for the domain name is mapping with that. This is the domain name. dns.c.umas.edu, it is a domain name. So that is a, so mapping with the IP and it is get back. This is exactly, so requesting host. Requesting host is CS poly.edu. I don't know this name, but I ask this server. So the, so no name is not getting, name to the IP address will be get back. So from the, so authoritative DNS server to the requested host. This is a iterative query what I explained here. So that is exactly recursive query puts a burden, name, resolution, and contact the name server heavy load to the upper levels of hierarchy. So you can see that again it is a first is a, again the iterative query, recursive query. It is a first it is opposed to that. So local DNS server, it is a requested query is not available. So requested query is a, so poly.edu, this domain name I want IP address. So again pass on to the local root DNS server, root DNS server, the TLD the servers. Again to top level domain servers, again to the, so request will be passed on to the authoritative DNS servers. From this, so through the DLD, it is a get back your okay. So again, whatever the domain name and IP address, so what exactly mapped, so it is get back the IP address of that. This DNS.umas.edu, that IP address is get back and pass on to the TLD server, DNS server. Again, pass on to the root DNS server. A root DNS server is a burden, heavy load and the burden. Again, pass on root DNS server. This is a recursive query. So again, we pass on to that. So under this, so what exactly we learned from the iterative iterative query, it is a don't burden on the root DNS server, but in the recursive query, it is heavy load to the upper levels of hierarchy. So that is exactly root DNS servers and TLD servers. Okay, top level domain server. So again, that is a pass on. These steps are very, very important, and you can explain this how exactly. So you are requesting the host is sending the I want domain name with IP mapping. So it is expecting. So for this domain, IP address it is required. So that is exactly, so the mapping of IP address. So with the domain name will be done by your DNS. So either TFTDS or authoritative DNS servers will give. So here DNS caching updating the records once the name servers learning the mapping of its cache mapping. So cache entries of timeout disappears after some time. TTL or time to leave. TLD servers are typically cached and local name servers and root name servers are not often visited. Cached entries may be out of date and best upon name to the address translation. If names post changes address may not known internet wide so until top level TTL, time to leave expires, update and notify the mechanism proposed in the IETF standards RFC so 12136 they are maintained. So this is caching and updating the records. So in this class, we have discussed about DNS, Internet Directory Service, service provided by DNS, what are the overview of how DNS works, we have learned.